Hey, so we're gonna finish up 5.2 in this section with just introducing maybe a quick trick on figuring out how to graph polynomials. So let's say you have a polynomial and thankfully it's already fully factored. And it looks like this. The product of x minus 4, x minus 2 squared, and x let's say plus 2 cubed. All right, so we know what the intercepts are. We can quickly pick them out just from the function. So take a second to do that. All right, so hopefully you found that the intercepts are going to be 4, 2, and negative 2. So 4, 2, negative 2. And now we know from the previous video that to find what's going on for the end behavior and between the roots, we have to plug in points between each root. And you're probably thinking, Weston, this is obnoxious. I don't want to plug in so many points. That's 4 different points we have to plug in. If this thing had more terms, it'd be obscene. And yeah, so there's actually a nice trick to get around it. We can get away with plugging in just one value into our function, or even just knowing what the end behavior is. So maybe we'll start off with just figuring out the end behavior. So we either want to know two values on the function, or one value on the function, or the end behavior. So the first way is check end behavior. We know that the degree of this polynomial, that the degree of f, we just sum the powers on each of these monomial terms, is 1 plus 2 plus 3, which equals 6. So the end behavior, because it's even, is the same on both ends. So it's either going to infinity on both sides, or it's going to negative infinity on both sides. And the leading coefficient is 1, which is positive. So that tells us by the rules we talked about in 5.1 that it's going to positive infinity on both sides. So our graph looks something like that. And now, here's the trick that we get to do. We just want to check if the sign changes or not. So if we plug in a number slightly smaller than negative 2, so let's say something smaller than negative 2. So like, that's something bigger, negative 2.01. We're going to have that, if we plug in f of negative 2.01, we get negative 2.01 minus 4 times x, which is negative 2.01 minus 2. And we get negative 2.01 plus 2, which equals negative 0.01. So this side is negative. This side is negative, and this side is negative. So the whole thing should be negative, which actually makes me think that we have a sign error somewhere, because our function says that it should be positive. Oh, sorry, I forgot that we have the powers associated with these. So we have 2 and 3. So that's going to give us this negative to the first power, this negative to the second power, and this negative to the third power. And so when you take a negative to the first power, you just get a negative back. The negative there switches to a positive, and our negative number cubed stays a negative. So this whole thing is positive. But if we plug in something a bit bigger, like negative 1.99, the sign of the first term isn't going to change. So it's still a negative. The second term, the sign still can't change, because the sign can only change if it switched from being less than 2 to greater than 2. So we still get a negative squared. But here, the sign actually changes to being positive, because we get negative 1.99 plus 2, which is 0.01, and that's positive. That's cubed, so then we get a negative times a positive times another positive. So the whole thing is negative. That's going to tell us that we're negative from here, and we have to connect back up to that root. But then, what happens with negative 2, with the intercept at 2? If we plug in f of 1.99, we're going to get 1.99 minus 4, 1.99 minus 2 squared, and 1.99 plus 2 cubed. So that's negative there, and clearly that's positive there. But over here we're negative, but we get squared. So the whole thing becomes negative, positive, positive. And if we plug in something slightly greater, like 2.01, again, we get negative. Now we get 2.01 minus 2 squared. And we get something that's positive again. But then this is squared, so it's still going to be positive. So negative times positive plus times positive, it's still negative. So on both sides, we stay negative. So it just bounces back down. This reasoning is a little complicated, but there's a general rule overall. It's that if we have an odd power, like here we have a power of 1, and here we have 3, then we cross the axis. And with a 2, since it's an even power, we bounce at the axis. And so that's because when it's an odd power, when we go from slightly less than that root to slightly greater, there's a change in signs. So the function changes in signs. But when it's an even power, because it's always getting squared to be positive, there's no change in signs. So that's why we bounce. We hit the root, we're negative, we hit the root, but then we stay negative. So that's what we call a bounce, where we hit and we bounce back. Bounce. And these are crosses. So that's a quick way to check what's happening, to be able to quickly come up with the graph if you're in fully factored form. But of course, it's always still going to work to just plug in points if you get stuck. These are also good ways to make sure that you did graph everything correctly. Now that you have two different ways of graphing, if both ways give you the same graph, there's a good chance that you did it correctly. If the two different ways of doing it give you two different answers, one of them's wrong because there's only one correct graph. But if they both line up, you're probably golden. All right, so that's it for graphing in these lecture videos. But certainly go out and just practice graphing. Find factored polynomials and just graph them. Or you can probably just create your own by just doing something that looks factored like this and give it different powers. And then you can go on to Desmos and check to make sure that you're correct. All right, happy graphing.